Welcome, everybody. Yeah. Clapping because it's going to be a great evening. I'm Lindy Elkins-Tanton. I am the director of the School of Earth and Space Exploration and co-chair for Interplanetary Initiative, which a moment ago was up on the screen. And I'm the PI of the NASA Psyche mission. And before I introduce Dr. Cady Coleman, I want to thank you all for coming and ask the thing that I always ask. How many of you, is this your first lecture here at ASU? Good. All right. Thank you for coming. I hope you come to many more. And for how many of you is this the first time you've ever come to an event on campus? Anybody? A couple people. Thank you so much. You're very, very welcome. I appreciate that. This, of course, is part of the charter of the university, that we really care deeply about reaching out to the community and becoming a part of our community in a way that I think is unusual for universities. And so when we throw a party like this, it's not just because we're so lucky as to work with Cady Coleman and that she's our friend and she's willing to come, but because we really believe that this is what universities should be doing, is reaching out. So thanks for coming. I want to say a tiny bit about both the School of Earth and Space and Interplanetary, just a tiny, tiny bit, in the hopes that those of you who are not already involved will get even more involved, because we'd love for you too. At the School of Earth and Space Exploration, this is our headquarters building. We're in 9 different buildings. We do astronomy and astrophysics, both theoretical and observational. We work with big telescopes. We work with exciting computer models, as astronomers do. We do planetary science, everything from trying to understand what happens inside and on the surface of our Earth, and also what happens in the planets. We're actually involved in 18 active NASA missions right now, which I think is the most of any university in the country. We're really serious about this, so that's nice. Yeah. And the reason that I think that that's so important is because it allows us to get students involved. I don't know if there's a more inspiring vehicle to get people excited about coming to school and doing their work and learning things than thinking about what a human space future might really be. And so we try to get as many students as we can involved. In the very first year of the NASA Psyche mission, we had over 100 undergraduate students involved with us. And now we have students from all over the country being a part of the mission. So that's what we're trying to do. And it combines and kind of moves really seamlessly into Interplanetary Initiative, which is the initiative that Michael Crow and I started together 2 years ago. And soon we're going to be bumping it up to even another level, which the announcements of which will be in the future if you're excited about this. What we're trying to do is really show a new way to put together research teams that is very inclusive, very diverse, and driven by questions. And we hope, going to roll out a new undergraduate major sometime in the next year that would be a 3-year Bachelor of Science focused on problem solving. So these are ways that we're trying to innovate and make a better future, and we're really glad that you're here. And so let me, without ado then, introduce Dr. Cady Coleman, who is our speaker today. Now, I told her, and I'm telling you now, that I'm going to introduce her as if she were a normal professor here for a normal academic talk, and I want you all to raise your hand when you realize that she's not. So Cady, this is how I always do these intros for fabulous academics who come to talk about their research. Cady got her undergraduate at MIT in chemistry, fantastic, and she went on to get her PhD in polymer chemistry at UMass Amherst. No hands up, this is totally normal, right? Right? Yeah, totally normal. This is normal. And then normally I'd say she went on to do a postdoc, but actually then she went into the Air Force and she worked as a polymer chemist on space materials, which is pretty cool. And then she was selected for the astronaut corps. And then she spent 6 months on the space station. And then, okay, ready for this? Ready to raise your hand? Then she became the personal space consultant to Sandra Bullock. Yeah. So please join me in welcoming Cady Coleman.
You hear me now? Okay. Slow start. That was an awesome introduction. Thank you. I'm so happy to be here. It's really my way of getting to say thank you to Lindy for having me. Where, sometimes when you meet somebody and they tell you about a place, I've been hearing about ASU for a long time, and it's a compelling place. And then I met Lindy, And she told me really what they're doing in the School of Earth and Space Exploration. And I wanted to be a part of that. And that's why I'm standing here tonight, and that's why you'll see me around here, I think, for a long time. And so tonight's mission is really just to say hello and introduce myself to the ASU community, and also just tell you some of the kinds of things that the work that I got to do with NASA. I was there for 24 years, two shuttle missions and a mission on the space station. They lasted a total of 180 days. There's a lot more days in that 24 years. And it was a very fascinating place to be in and to work basically on a mission of exploration. And that's why I came here, is to continue that mission of exploration. So I love to start with this picture, which is very special to me, and I'm hoping to you. If you look on the left-hand side of that space station, you can see the thing kind of hanging off the left-hand side with the tail sticking out. That is the Space Shuttle on its second to last voyage to the space station. And I know that because only 3 humans have seen that with their eyes. And that was myself and Dmitry Kondratyev and Paula Nespoli as we undocked in our little Soyuz to come around the Earth a few times and then land back in Kazakhstan and fly home to our homes. And so this picture is very special to me, but I think it's important because it symbolizes what important work so many people have done together. So I'd like to just share some of that with you. Real quickly, background on the Space Shuttle. I am a scientist, and my first mission was a mission to do about 30 different science experiments. There were 4 of us that were scientists and then a flight crew. And it was the longest mission we'd ever had on the Space Shuttle. And our job was to, in fact, this patch is not on this spacesuit, but our job was to basically understand how are we going to conduct experiments on that space station. How are we going to have enough data? What kind of data do the scientists need? One really important thing we figured out was that we actually can't teach people like me enough about what we're looking at up there in space that we can be as good as the folks who are here on the ground that really can look at those samples and see them in great detail. And we found out that we need better instrumentation so that people on the ground can really see what they need to see, and that they need to educate us, basically to make sure that we can make sure their experiments are working. So we learned lots of important things on that mission, and I was really pleased to be a part of it, the longest one to date. And I remember the feeling of landing and just landing on the runway as the wheels touched down, and my thought was just, this is just too soon. Why did we have to come home? We have so much work to do up there. And I'll show you a little bit about space science. This is my second mission. And we have a lot of astronomy and astrophysics folks here in the payload bay of that space shuttle. Right in there is the Chandra X-ray Observatory. Just days before it went to space, and it's been out there. It was on a 5-year mission. It's an X-ray telescope, very special. It's 80,000 kilometers away from the Earth at its furthest point. It's not like the Hubble close to the Earth where we can fix it. And our crew was in charge of launching that telescope. People thought about what instruments they needed 25 years before this. Oh, wait a second. Let's not do that. 24 years before this date. So such a long time ago, they said, if we had a telescope that could see these things, we would begin to learn more about our universe. And they waited all that time, doing other work, of course, to launch this telescope. And when it was up in space, we launched it from the shuttle. I had told them on the launch pad when we literally tucked in that telescope into the payload bay, and I looked at some of the scientists, and they almost just couldn't speak. Because, they had waited so long for this instrument to be built, to be launched, and here it is all ready, and everything is riding on it. And none of us knew what to say. And I finally just looked at them and I said, I promise to take very, very good care of Chandra. But I cannot promise to bring her home. And Chandra was supposed to be working for 5 years. That was 1999. Chandra is still bringing in data day after day. So I love being part of something that still lives. So I'm going to talk mostly about the space station and what it's like to be up there, but also the kinds of things that we learn from space crews and how we can learn some lessons that I think are very applicable down here on Earth And I already see so many of these things employed here in the School of Earth and Space Exploration in terms of how people really are brave and open to each other enough to get the really important projects done that we have. So this is me celebrating my 50th birthday. And the next day, I launched to space. Let's see if this will go here. The next day, hello. Oh, always these things. Every once in a while, it's going to ask me to be an ASU guest. I am not a guest. Okay. Anyways, if you just turn off wireless, you want to? So this is my 50th birthday. Why don't you just go to the next slide so I can keep going there? So this is our Soyuz launching, or actually not. This is not ours, but it was a good picture to show you. It's a tiny Russian rocket. It is a tiny spaceship to be inside of, and it's headed to this large space station, which is like a city in space. And this is what the Soyuz looks like. And it's about the size of like 3 smart cars put together, but we only live in one of them, and that's right in the middle here. And so this one here is like our living room in case we have to stay up on orbit longer than we thought. And here is our probe that's going to attach to the space station. And this is all our propulsion and solar arrays and things like that. And so when we come home, we actually only come home in this little part right here. But going up there, this, I think, is what you think of when you think about going to space. Being in a small place with 2 or 3 people that you probably did not get to pick, who may or may not be your best friends. And that's what it's like. It is a very small space, but that's only the taxi ride. Getting to space takes 8.5 minutes. Parallel parking at the space station, a bit longer, many hours. And I was actually one of the last crews to have the privilege of, we used to take about a day and a half after we launched in the Soyuz to basically circle the Earth and make sure we're really ready for docking with the space station, which is a big deal and complicated. And so there was just the 3 of us in this tiny little craft, as big as like the 3 of us sitting together, orbiting the Earth. And thinking about, 50 years, this is the 50th anniversary of Apollo, of landing on the moon, getting to do just what those gentlemen got to do. My thought was that this is an amazingly special place, space, but it's always belonged to us. We just hadn't been here yet, or I just hadn't been here yet. So it's a really special journey. I like to show you how big the space station is. We don't live on the part that is end zone to end zone. That's mostly the equipment. That's where the spacewalk's going to be taking place tomorrow, is changing out some of the batteries that are out there. Those are batteries that are connected to the solar arrays here. And actually, you can see some of these pallets of batteries here. That's what they're going out. They're going to climb out from the airlock, and they're going to climb out there and change batteries. And the part that we live in is along the 50-yard line here. And it's about 10 train cars all strung together, but some of them are up and some of them are down, and none of them have the seats in them. So that's the size that we're talking about. It's a really large thing. This is about a 3-minute movie that just shows a little bit about getting ready, being on board, and what it's like to live up there. You notice the patches from the mission. They all have 6 people on them, yet we go up in groups of 3. This looks like animation, but it's real footage. And I think that's so significant that what we used to think about in terms of designing science fiction movies and writing books, these things are now real. Real people that now you know me, are launching into space and working up there. And real people that right here at ASU are building instruments and launching those into space. And all of those things are human endeavors. This is getting ready for launch. We sign the door of the room that we stay in Russia. There's a lot of Russian traditions. I'm waving to my son and my husband. My son was 10 at the time that I went. Now he's 18 and on his way to college next year. And we all agreed that we would take small steps and walk slowly. And then everybody was a little nervous. And I literally had to run to the launch pad. So this is that launch. And so I've launched 3 times. And there's nothing like it. And especially, this rocket is tiny, so you feel every single little move. And you realize that once those engines light, you are going somewhere, and you are not going to stop until you get there. So this is the Soyuz on its way to dock with the space station. And I love this picture. We got up there right before Christmas. My 10-year-old actually asked me, a little bit plaintively if I couldn't wait until after Christmas to go. And I explained that I really didn't control the timetable. But this is capturing a supply ship. This is the second time we've ever captured a supply ship from the International Space Station with the robotic arm. It's like a pickup truck pulling up to a factory, and if something's going to happen, if there's going to be a crash, the factory can't move. So it's a really critical operation, and it takes some really special training to make sure that you do that the way it needs to be done and you're ready for anything. You saw the origami that we're building up there. We did a lot of supply missions after that, but the origami were for the Japanese people for a very serious reason, actually. We were up there during the Japanese tsunami. We had just captured their supply ship. Mission control was affected. Space is a family. And I think the minute you walk in this building, you feel that in terms of the people that do research here. And it's no different for folks that are in space and the mission controls and the people that we work with on the ground. So now this is a shuttle mission coming up to bring the last piece, giant piece, of the International Space Station up to us. Right there in the payload bay, that silver can there, that's a new module right back in there. And that's a new piece of the space station that's going to allow us to have a lot more experiments up there to do. This is the actual thing that's going to dock and connect to the space station. The shuttle is doing a pirouette underneath us. We are taking pictures. It's probably the most nervous I was on the whole flight, was making sure you take those pictures correctly. That helps us diagnose whether the shuttle will be good for re-entry or not. Docking. And we've been alone, the 6 of us, for a couple months, and family arrives. Just like on a major holiday when folks show up at your house and you've been getting ready for days and days and days, and here they are, we're getting ready, where they're doing spacewalks, and we're the support crew on board, making sure that when this shuttle crew comes up, we can have everything ready so that we can get the maximum amount of work done when we have that many people with us. This is our robot. The little tiger there belongs to my son. It's Hobbs. The robot in this picture is the one on the left. This is a robot called Robonaut, and it's part of a series of experiments to understand. I mean, we have a lot of really important work to do up in space, and people cannot do all of it. And so how do we maximize the amount that robots can do? And you have to start somewhere. So we brought Robonaut up there, and we were experimenting with what kinds of tasks he could do. Note the position of our kitchen table there, not horizontal. And then if you think it through, you'll realize that it doesn't really matter whether the kitchen table is like horizontal or vertical or at an angle, because nothing's going to stay on it unless it's duct taped or Velcroed or something. And actually my crewmate Paolo was the one that had the vision to change that table from horizontal in a place that had been for 10 years to that kind of angled thing. And the reason was that every one of us had bruises on our hips. This way for going to the Russian segment, and this hip for when I came back, because it was in the way. And it took Paolo, who thinks about things in a very visual kind of way, and you never want to design a new kitchen without Paolo. And you certainly don't want to design the kitchen on the space station without him. And out of 10 years of people on the space station, he's the only one that saw that. And so I just think it's just a way of emphasizing that everyone here has ideas that are important that other people don't have, and it's important to speak up about them. So about the work that we do up there, just some quick slides about science. And I think that the way to think about it is that we're living in a place where, even though the forces of nature still apply, because gravity is so small, it really changes the way we're able to see things. And I call it having a different lens, a different way of looking at things. It's really important for us, both for space and especially for Earth, to understand, what do liquids really want to do? It's important to understand that for every process in a factory that involves flow through a pipe. It's important for pollution and oil recovery, those kinds of things. It's important in our pipes as well to understand those forces. And so when we go to space without gravity, surface tension becomes the dominant force. And we have a new way to see, what do liquids really want to do? And that same principle of without gravity, it gives us a different way to look and to measure. Combustion is a really good example. The flame on the left is an Earth flame, and on the right is a space flame. And the Earth flame is like the ones that you see on TV and at home, where the lighter gases are rising, new fuel is coming in, it's this big, exciting cycle, and it's actually really hard to measure things. There are measurements that we have to make in less than a second to determine the slope of a line. And on the Earth candle flame, we make those measurements in less than a second because there's no gases rising, there's no things rushing in. Sure, it's different, but it actually gives us a window into taking those same measurements over 30 or 40 seconds to establish, with a lot of data points, the slope of that line. So taking away gravity gives us a way to look at things differently. And here's a spherical candle flame. Important for understanding combustion and the production of pollution and soot down here, and important for understanding how to fight fires up in space and how to make sure that you don't have them on a spacecraft. And something that's really important to me is that the work we do for space and for exploration, it's compelling. People are excited about it. People want to say, I worked on that, I helped that. And I think there's something very human about wanting to advance our place in the universe. And yet, those same things that we learn come right back down here to Earth. This is me growing plants. I'm not a big plant grower, but I learned. And let's see if this will, oh, this is so funny. Here we go. Karen, do you want to just if you turn the Wi-Fi off, if you just turn the Wi-Fi off, it will do it. Well, every once in a while I'll just do that. That's okay. Sorry about that, you guys. So this is plant growth. And so learning how to grow plants in a place where it's hard to grow them, where we don't have good soil and we may not have enough water and we have to recycle these things. Sounds familiar, doesn't it? So these things that are important for space and exploration are also really important right here on Earth, and yet going to space gives us a different and unique lens that we don't have from other things. A lot of really interesting medical studies I was part of. I'll get a physical at your taxpayers' expense for the rest of my life every year. And so they continue to measure lots of things. They have lots and lots of samples. And I was particularly proud of the osteoporosis work that I did, really just by living up on the space station. When we're up there, if we do nothing, we lose bone 10 times faster than a woman who has osteoporosis who is 70 years old. So what she loses in a whole year, I lose in a month if I do nothing. And the good news is it happens so fast, it's easy to measure, and we tend to have cleaner medical histories than folks that are older. And so, except I'm older now too. And so in this picture, you see that we can suffer great bone loss, but I myself, and not because I'm Superwoman, came back with all of the bone that I launched with, at least the same measured amount. It doesn't actually mean probably that my bones are the same. And so I probably did sort of lose bone. If you think of your bone like a pipe, I probably lost bone out of the meaty middle and built bone by exercise. So that's the good and the bad news, is that exercise is here to stay. So you build bone up on the outside of that pipe. Now, what does that mean structurally for me as a skyscraper as I get older? We'll have to see, and we'll be measuring those kinds of things. But it's really unique research that we can do up here. Here at ASU, they have a lot of research that goes into CubeSats, and they're a huge possibility and an on-ramp for students, for people with ideas, small, not giant rockets, but small satellites. And a lot of the understanding of how to make those work comes from experiments that we have on the space station. We've learned some things from this experiment called spheres. These are little spheres that are CO2, they have little CO2 cartridges. And so they're zipping around, interacting with each other. We're learning about spacecraft coming together. How could they fix each other? How do they approach? How do they get away? How do they take pictures of each other? Learning those things. But the best news is that in order to do a new experiment, all we have to do is uplink new software. And so there is a contest that is all over the country for middle school students. And there's a contest for high school students. It's all over the world, and college students that are all over the world. And so we can actually hold these contests on the space station. The astronauts that are up there will actually be going ready, set, go. I mean, the heats are all down here on the ground, and the finals take place on the space station. It's a pretty wonderful, multi-dimensional experiment. And for the same amount of crew time, you could just be learning about rendezvous. But instead, you're inspiring and doing hands-on things with a whole new generation. And that's some of the things that I think Lindy was alluding to. And so always trying to see how could we really multiply that time. I'm not really going to talk much about some of the things we do, like spacewalking up there and robotics. This is us capturing that Japanese supply ship, Paolo and myself. But I would like to talk about what it's like to do that and what I think it means to teams down here on the ground. This is Paolo and myself in the cupola with all the robotics set up. When this is a 16-ton supply ship, and it has to be done right. And if you do it wrong or if it loses its mind, it can be a very dangerous situation. It's something we'd only done once before, a couple months before, and so ours was still very much a trial, and we learned a lot doing that. And I'm extremely proud to say that this is something that is completely routine on the space station now. Supply ships from SpaceX, from Orbital Sciences, from Japan, from Europe are coming up, being received by the crew, unpacked, new experiments all the time, just like we planned. It's really wonderful for me to be part of that plan. And people carry out that plan. This is our crew. This is myself, Dmitry Kondratyev from Russia, and Paolo Nespoli from Italy. The three of us went up in that Soyuz. This is a picture of our Soyuz crew really excited about going to space. So I say that actually not to make fun of my crewmate, Dmitry, honestly. But because that's what we're chuckling about, right? Boy, that's a face that doesn't look too excited. And imagine me when I'm going, hey, Dmitry, here's my good idea. And then there's that face, right? and so here was my big lesson, was that this is a picture of Dmitry excited about going to space. And seriously, I needed to learn that and understand that. And when I have an idea and I want him to hear it, I need to realize that I can't rely on what I see on the outside, and that we come from different places, we have different cultures. And so we had to find, and this is the... So remember when we're a group of three, we go up, there's already 3 up there, so now we are 6. 3 go home, and then 3 more come. So it's a sort of a 6-month cycle where every 3 months somebody is coming or going, if that makes sense. So even though we're part of a crew of 6, we're part of 2 different crews of 6. And so it really means that you have to figure out how to maximize what you can do with this crew. And I'm hoping that I have explained to you, did anybody see this movie? I'd like to think that if everyone watched this movie, we could change the world. To me, it's a very important slide. I'll sort of go ahead here and just show you why. This picture was taken actually before the movie, but to me, just the visual reference of there's really, it's hard to miss me in that picture, right? I mean, we did have a little communication trouble over wardrobe, okay? I will say. It's a longer story. I'd be happy to tell it later. I was right. One of the guys looked at the other and goes, "You didn't tell her," you know. Anyways, but there we were at the White House with President Obama. And this is Katherine Johnson, a mathematician that designed the trajectories for the Apollo astronauts to Apollo, Gemini, Mercury, and the shuttle to get to space and safely home. So she was a person that was a mathematician that did those things, designed those trajectories. And we call this movie Hidden Figures, but in this picture, she is a woman of color. In almost every scene in the movie, she's wearing a dress of color in a sea of white. And it's hard to miss her, isn't it? And yet, we didn't see her. But there's more than the visual sort of reference. And on all of our teams, I think that all of us bring things that we feel like other people on the team don't see. You know, it's easy for me to say, you know, my serious Scott Kelly colleague, where I said, oh, the robot's the one on the left, you know, that serious guy, serious all the time, make that judgment. And actually, you know, not realize that there's a whole person there. And I'm only seeing the little top of the iceberg. And in order to be a really effective team, you have to find a way to connect with each other. And some people, it's easier. I mean, Paolo's from Italy, he's very open. I did have to learn how to eat lunch in order to relate to each other. And because, seriously, I was never going to find out how Paolo Nespoli was really doing unless I had a meal with him. It was the same on Earth. It was the same on the space station. Nicole Stott and I have in common that we have kids about the same age. There's a time between 7:30 at night and 11 o'clock that we don't email because we're busy at home. And we're going to get some things done by email after that. And so, easy for us to connect. As I said, Scott, not as easy. And yet, this guy was up there. This is Scott too. And it's easy to just go, oh, he does that, he's going to be like that. And you have to take that extra effort. And you also have to be brave enough if you're the person who's got something to say, to bring it out. And you have to be open enough to be the one who listens. And I will even say that, maybe in learning to work together and maybe running a meeting, letting other people talk. It's scary to do that sometimes, especially if you're the leader. I mean, what if the meeting gets out of control? And I'm a silence filler. I mean, I see that little silence and I jump in there and I feel that silence. And it's a little scary for me to leave it open. And so you have to be a little brave to leave those silences open and see what people who are a little slower to raise their hands have to say. And Al, Drew, and I got to know each other on the ground, but also on orbit, doing some unplanned things that went really, really well. And when he came in from his spacewalk, this is my favorite picture out of any that's ever been taken for the space program, because to me, it's the epitome of exactly what being on a crew is about, where we worked hard, we really dug deep to just do the best that we could do together, and the mission was really the paramount thing. And when we did it, this is how we felt. So one of the ways to do that, I think, to really reach out and find each other is to really look at what are the things that we each do that are different. Oops, this is me multitasking. Karen, can I ask you to do this? Oh, now I found the mouse here. There we go. Okay, we're good for a little bit. And so to look at, I think you have to dig deep and you have to have weird conversations. I mean, if you don't ask people, you'll never know. Someone wrote me a note just the other night and said, okay, so do you know when so-and-so, guy astronaut, do you know whether he was the disco champion of what city? And I'm like, hello? I mean, I've known that guy a long time. Music is my thing, and it's a way that so if you want to know something about me, I think talking to me about music is one way to do that. And I think it brings out this sort of brave and open aspect that I talked about, where in order to share your story, you have to be brave. You have to be, I'm not typically sure somebody wants to hear my story. I know because it's space stuff, they probably do. But are the stories that I have to tell, should I really be the one saying, hey, listen to my story, you need to hear it? There's a certain ego in there that isn't always, something that I own. And this was something I felt like I had to be pretty brave to do. And that was to go up to space as a flute player, as an average flute player who is decent and loves to play. I brought Ian Anderson's flute up there. He's the person who brought the flute to rock music. And so that's Ian. And we played a duet between Earth and space on a very, very special day. So this duet first played down on the ground. Ian Anderson was in Russia. I was on the space station. It was the 50th anniversary of human spaceflight. Yuri Gagarin launched from this Earth into space on April 12th, 1961. And so 50 years later, we were in space. Ian was in Russia. I was on the space station. And we made
Thanks,
music
Colonel
between Earth
Catherine
and space.
Coleman in the International Space Station. We should remember that today's cosmonauts, scientists, and astronauts are still every bit the rocket heroes they were 50 years ago. So, from the cultural city of Perm in Russia, let's salute Cady, Dima, and Paolo up there in orbit, and of course, the legendary Yuri Gagarin. Go safely.
I actually show that at the end because I think it's fascinating. It got to be just normal to throw things around like that. And I had a whole new set of rules to learn when I got home, I'll tell you. So I'll show you just a little bit about living in space. I love this because it shows it's movies that I wish I made. This is my friend Mike riding on the treadmill. Now he's washing his hair. Even if you have long hair like me, you see my big hair up there. It's this same hair. And it's just that gravity has a profound effect down here on the ground. This is the sleeping quarters. We have sleeping bags. You don't actually have to attach them to the sleep station. It's like a phone booth. And so, you're not really going to go anywhere. I typically kind of slept all curled up like a little ball, and I wake up sort of upside down under the computer desk and things like that. The Russians sent up fresh food for us. in the form of lemons, pickles, and onions. Thank you. This is one of our favorite places, the cupola. And look at this here. So it looks like they are moving to the left. But think about it differently for a second. What if they're standing still and the station is moving to the right? There's always a different way to think about it. And this is why I show you the movie. It's my favorite little scene. And I mean, this is Satoshi Furukawa, very shy, wonderful medical doctor. And he made this movie. I mean, and so, you know, this very shy guy knew that people would want to see that from space. And he made that film. And I just delight in showing it and just running around on the space station like this. You can tell that it's a little practice. There's a little practice needed. So let me just, I'm not quite wrapped up. I'm going to do about 10 more minutes, and then we'll certainly take questions, and there'll be a microphone that circulates there. But I just want to take you outside the space station for a little perspective. Now, this picture was taken from a shuttle of the space station, and then the Earth in the background. So you can see that we're actually pretty close there. And this is our window, our cupola window. And the fact that we had a different kind of window, not just like a little portal, where if I want to see Hawaii go by, I have to know exactly when to look and exactly where. And the fact that the camera might not be able to get exactly in that place, and I'm probably going to scratch the window when I try to do it. Having this cupola up there where I can be up in the cupola and there's windows around me and I can look off in the distance and I can see someplace, like maybe someplace like home, coming. And then it's right above me, above the big window. And then I can spin around and it's going to be receding in the different distance. And so the fact that we can have this window that lets us really be part of the view, I think is a very much more human way to experience the place that we really are. And I think it's a really important perspective. Here's the East Coast. So I'm a Massachusetts person, so I always have Cape Cod. My first flight, I flew with a guy from Massachusetts, has a pretty strong Massachusetts accent. We both got to see Massachusetts during the day from space at the same time. And he looks down and goes, "Oh my gosh, it looks just like the map." But I love having this perspective. And, you know, and for me, this is, you know, it's wistful, it's home, and now it's receding in the distance in the sunset. And yet I know I'm going to be back, you know, in just a few hours for Paolo, Italy, indeed, shaped like a boot. Things that, you know, here it's beautiful from space, but think about the devastation of a hurricane or typhoon underneath. And in this picture, it's not pretty, but this is Japan during the tsunami. And we took pictures at night and during the day in order to understand how much power how much power Japan had left and how much water, where the water was. And it really made us feel better to be part of that. That was why we built those white crane origamis. They represented hope and rebuilding for the Japanese people. And the film of us making those origamis was on billboards all over Japan for a long time. So I love the perspective. I came home from my first flight, and I always think of the Sinai Peninsula with this sort of picture here with Egypt and Israel and everything in one place. And I was in a taxi, and I asked the guy where he's from. He said, "I'm from Egypt." And my first thought was, I was just there. So it really makes you feel like a citizen of everywhere, you know, of our very wonderful universe. This is the northern lights and the southern lights. You know, we're able to make observations from space about our planet that can help understand it. And sometimes the pictures are just actually beautiful. It's just something that, I mean, it might be art, it might be land, it might be water. You know, it's just really neat. And so using the art of perspective, of looking at things differently, that's the last thing I want to really leave you with as I show you a few more slides, which is that, you know, if you just try to stretch your perspective and see people and see jobs and see work in a different way, that's when we're going to realize that we have a lot more options than we really thought. And I think in this picture you can see me because I'm the one with the big hair, right? And yet, isn't it a little easier to see me here? And, you know, and so if I go back for a second, I mean, if you turn your head, right, then I think you can kind of see me a little bit better. And so there's a way that we're used to looking. And we actually lose stuff in space all the time because we forget to look. Actually, we look on the ground. and it's not going to be there in space. So learning how to look in a different way. Here's our, we had a mission where we had 4 women up there. And this is Tracy Caldwell on the bottom. She's a chemist. And Stephanie Wilson is an aeronautical engineer, bottom right there. But you barely see the 2 people up top until you see them in the way you're used to looking at them. And so, I would urge you to, I think this is the reward that you're going to get, is that you're going to have a team that you couldn't believe ever could happen. There's a myth out there that NASA picks teams and they think about who might work nicely with whom, and it's simply not true. We don't have the latitude to do that. When they are putting a crew together for the space station, it's about what skills people have, what stage they are in their career, what country it is whose turn it is to have their astronauts up there. It's an amazingly complicated question, and do you like each other is not part of that question. And it's amazing to me, but we figure it out. We figure it out in training, and then when we're up there, we really know. Sooner or later, it's time to come home. And I would have lived another 6 months up there in a minute. I really loved it, and the fact that we were doing work that I felt was so important. It takes about a month to get good at things, and then once you're good at things, you just want to stay and get more done. But it was time to come home, and this is our landing. Physics in action. You can see what side of our spacecraft was hot. And I always tell people the bigger they are, the harder they fall, and I landed like $1 million. So maybe in this case it was good to be short. It's hard to know. And good to come home. I loved being in space, but I love home. And I know this doesn't look like Arizona, but I commuted between Houston and Hartford, or Western Massachusetts, for 24 years for my job because of the mission, because I felt like I played a part in the mission. And it was something that was hard on our family. It was hard on all of us. And at the same time, it was really what we all as a family chose to do. This is coming home. My son was 10 when I was up on the space station. And it was really hard to leave him behind. And people tend to ask the women astronauts, do you mind leaving your family? And it's completely an injustice not to ask that of the men as well. All of us mind, and whether you are, working here at ASU and staying late and getting something done for someone, because it's your job to make sure that that really happens so that the bigger mission happens, and you're missing softball and soccer and all those things. It's hard on families. And this is a pretty wonderful picture of when I first got to space. My son, and this is Dimitri's son, got to talk to us from space, or from Earth. And leaving him behind was hard. I left him with his trusty cat. He insists that I share pictures of him now that he's grown up. And so hopefully you'll see him here on this ASU campus at some point. And with this, I just say that that curiosity that kids have, that's really something that we have to preserve, and we have to think about and never ever lose, and not feel like we're childish to express a wonder about something that just seems magical and interesting. And when you suddenly have a revelation, when somebody shows you something in a way that you understand it and you go, oh, that's how that works. I felt like that today in beginning astronomy. I was in Jenny Patient's class, and she was talking about neutron stars and how they work. And it's not something that I know a lot about. You might think I do, but I don't. And she explained it in a way where I'm like, oh, that's what they've been talking about. And and to have joy in those moments, and never forget to look. But it does take a whole team. And it's my husband. Somebody has to hold things up at home if somebody like me is going to have the job that I do. And I have a village of girlfriends that help both me and my family, which I depend on. And our lives are, I think, a marvelous mixture of some of the art and science that Lindy alluded to, where we both we explore in different ways. My husband is a glass artist, and he's known for making glass planets. And there are things that don't really exist out in nature, we don't think. But it makes people think about, what would they look like? What are we going to find? And then somebody who's more engineering-like is going to look at this and go, if things were like that on that planet, we had better be building a different rover, because that doesn't look like a smooth planet to me. And so it's an interesting interaction between engineering and science and art and technology. And all of this is the power of space. And in my retirement, so to speak, I retired from NASA about 2 years ago, the end of 2016. And I feel actually compelled to use some of the power I have my superpower, having been to space. People will, I mean, many of you came to ASU for the first time. Many of you came to a lecture for the first time. And I think it's because space is compelling. And I am determined that we use that power for the power of good, for making sure that everybody is part of the mission. I was part of helping the first 50 Girl Scouts ever to camp on the, or Scouts of any kind, camp on the White House lawn. You know, using that power to try to make things happen that can, you know, be showy pictures that get shown, you know, in Girl Scout magazines. And who knows what this is making girls think they could do? Probably anything. And that's really the whole point. And so the last thing I'll leave you with is that every one of us has, I think, inside us at least one idea, and probably more like 50,000, but at least something inside that we know we should bring out and have others help us use. And the example I will use is I was part of the Eclipse for CNN and Volvo. And they wanted 4 of us to sort of be spaced across the country and narrate the solar eclipse. This is what it looks like from space, by the way. And so they asked 4 of us, 2 men and 2 women. And that's pretty great to have 50% men and women. And I said, well, to me, I want more people to identify when they see me. I want them to see more of themselves. So what if it was me and 5 girls? And so they agreed that we could have 5 Girl Scouts between the ages of 8 and 11. And we had, you know, immense numbers of views, more so actually than the other folks. But these are really, I mean, you saw my family and sort of everybody, and it was amazing to see the eclipse. Here's the girls. But these are really the heroes. If I'd known what I was asking, when I said, can I have 5 girls between 8 and 11? Oh, by the way, it'll be 90-something degrees. We're going to have to be out there for hours and hours. We're filming in the round, and so there are no production people out there with us. It's only the girls and my family and I, and we have 12 minutes of live TV to fill. I mean, it was extreme, and we had to rehearse it. I mean, if I had understood how hard that would be on everybody, I would probably never have suggested it. But this crew knew how hard it was. And they said, let's do it because it's worth it. And it was. So every one of you has something like that inside of you. And so as we celebrate 50 years of space, 50 years of people being up in space, landing on the moon, seeing our planet from a perspective that helps us realize that we all live in space. Let's keep that in mind. And I look for your questions. So I think we've got microphones running around.
Just get right there.
Go ahead.
A simple question. How often do they have to change the batteries on the space station?
It's like every 5 to 10 years. Not often unless there's a malfunction. I mean, it's been a planned maintenance that the batteries gradually degrade in performance, and so this has been a planned task. Excuse me, for a long time. Next. Oh, so what is Sandra Bullock really like? You know, the guys on my crew they said, you know, this is really so not fair. Like, we have only you, 5 of us and you have Sandra Bullock? And this came about not because of NASA, but my little brother, you know, struck up a conversation with a guy at a wine festival, turned out to be Sandra Bullock's brother-in-law. And he said, you know, my sister-in-law is making this movie about astronauts. Maybe your sister would talk to her. He said, you know, my sister has been on the space station with 5 guys for 4 months. She would talk to anybody that was a girl. And actually it was really neat because we all, as a crew, it was a great crew project. We thought, you know, what does she want to know? And if you look up a video called Splitting Hairs in Gravity, mostly she wanted to know 2 things. She wanted to know what it was like to move up there. And what I explained to her and then had my friend Karen Nyberg do on the space station later so we could sort of show other people was that if I take 1 hair from my head, 1 long hair, and stretch it out like dental floss, and I push against something, if I push hard, I'm going to break that hair. But if I push slowly, I would push myself across this entire auditorium. That's how little force it takes to move up there. And the other thing she wanted to know was what it felt like to live so far away from everybody that you love. And that's a hard thing. And at the same time, I just felt so much that I'd be back and I was doing the work that I was really meant to do and prepared to do, and that I was really just loved being part of the mission. Somebody else? Yes, in the back. Yep.
Yeah, oh, this is really loud, sorry.
Go ahead.
I was curious. God.
So can you ask that question again?
How many computers were there on the International Space Station?
How many computers were there on the International Space Station? I don't even really, there are so many. I mean, there's a whole bunch that run all the experiments. But that run the space station itself, I would say that there are 6. And so we always have like 3 prime and backup, and the Russians have some, and there's just really a whole bunch of them. And we know that, and there's actually one that's always asleep. And the only time it ever wakes up is if the other ones all go to sleep. And that's when that one wakes up. And we practice making sure we know how to make that happen. I'll give you a funny thing. There was a shuttle crew coming up, and two of these folks, one played guitar, one played piano, like you would not believe. I play the flute. They're coming up. We've played music together on the ground. I said, better get ready for the guys. We're going to play music. Oh, I'm going to find the keyboard. A long time ago, a keyboard, an actual Yamaha keyboard that runs on D batteries, went up to the space station. And I knew it was there. And so I looked up in the inventory management system, and I said, keyboard, where is it? And there were like 100 entries, because every computer has a keyboard and a part number. And so then I had to think about, well, if I were storing that thing, where would it be? And that helped narrow down where it was, and I found the thing. Okay, next question. That was a really nice question. Thank you.
Going to the space station and coming back, how has your cultural competency changed in the way that you interact with people here on Earth? And then how, as citizens, can we begin to make steps toward that in the way that you've seen changes in yourself?
So I felt so lucky to be there. I mean, I felt qualified, and at the same time, just so privileged to have this job and to have this view. And I feel strongly that it belongs to everyone. And I feel like in order for me to have gone to the schools that I went to, done the jobs that I did, acquired the skills that I did, it didn't just happen. I had really I had a lot of help and mentoring, but there was also times where I basically had to sort of cheerfully show up to parts of a mission, to a meeting about the mission that I wasn't invited to. And I wasn't invited not on purpose. It's more, it never occurred to them that I might be a part of that part of the mission. I'll use an example, spacewalking. Actually, they're like, she's kind of small. I don't know if she'd be a spacewalker. And when they're making the list of who to, hey, we're going to see this thing, we should bring everybody that needs to see it, they would actually forget to invite me. And so I would just go, hey, I heard we're going to see the thing, I can't wait. And I just feel strongly that you shouldn't have to cheerfully show up, that we need to change that. And I find myself, making suggestions here and there. I sat next to a guy on the plane on the way here, works for this aviation company that has a special mapping function. And a lot of pilots like to work for them because they get a lot of hours. And it was talking about what a great job, that people really like it. They pass through, they often get enough hours, they go work for the airline. And I said, you ever considered how many women pilots do you have? And it was about 25%. I said, what if you were known as the place that was 50-50 men and women pilots? Wouldn't that be cool to know that you are balancing the scales in that arena? And so I find myself making these kinds of suggestions, and and some of them are rude. I mean, in a way, it's like, what business is it of mine, that the guy sitting next to me? But I find myself compelled to just share this point of view that we have really hard problems to solve, and if we don't invite everyone to the table, we are not going to solve them. And it's time to make sure that everybody realizes that they're invited and they belong there.
Excuse me. Can you give some background how the space station was built.
How the space station was built?
I mean, the first place, because nothing exists. How it was built, actually.
So they had to think really hard about the beginning part, like how do you put the first piece up and the second piece, and which one is smart enough to meet the other one, that kind of thing. So they thought that out really hard. And if you Google space station assembly, I think you'll see a very cool video of what I'm talking about. But basically, they put the first piece up, and it was smart enough to be able to, when the second piece came up, be able to actually let the second piece attach. And we basically then had enough capability that there was power, there was storage, and there was life support. So we needed both pieces. We couldn't have all that in one piece. So we needed both pieces. And then between Russian rockets and the space shuttle, both having this huge cargo capacity, sort of being able to bring 50-foot things up to space, it was brought up piece by piece. And all those pieces are made by different countries all over the world. That's something I really haven't covered here, except for mentioning that Dmitry and Paolo are from Russia and Italy, is that it's an international space station. And there are many, many different countries involved. The major sort of partners are Russia, the US, Canada, Japan, and a bunch of countries in Europe. But I would say there's about 40-something countries that are actually involved in doing experiments and constructing the space station. But literally piece by piece, almost like Lego, but we thought a lot about what are the attachment mechanisms, and it's been rearranged since we built it, because as things come up, we make more optimal situations. Somebody else?
So how did you get a flute and a guitar up there, and do those now have permanent residence on the station?
Good question. The guitar stays up there. The guitar went a long time ago in one of the early space station missions, and it stayed up there. And I ended up because the space shuttle was still flying when I went up on the Soyuz. I was allowed to bring. You're allowed to bring up a thing about like this that are things not for you, but for other people or for sharing, not private people, but for sharing. For something that will make some ripples, that will make people think that we all live in space because we do. And so I don't have the picture here, but I brought a scarf for Sandra Day O'Connor, who I know is very local here. And I was invited to her 80th birthday party here and met her. And it was a very profound evening for me to meet someone who was so wise and so brave. And she gave me her scarf that is known as, her scarf that is her Supreme Court scarf. And she was known for her kitchen diplomacy. So up in space, I unfurled the scarf, and I cut a corner off of it. And I left the corner up on the space station so we could have kitchen diplomacy. Okay, I think we're done, but I'd like to say that I'll be back, because I've been invited to hang around and help ASU explore as the University Explorer. And so I'll be around for a long time for these kinds of questions. And I love that people have them. We've had some really unusual questions. And keep asking those questions, because together we're going to find answers, and it's going to be fun.
Exactly. Yeah. So before we say our final thank you for Cady, I would like to just underscore the really momentous thing that she just said, in case you hadn't gathered. She has actually joined ASU as our University Explorer, and so she'll be part of our community now going forward. And so as a special thanks for this very first talk to everyone, we have a little gift. It is really, we're giving you not just the space station and the Earth, but the whole solar system.
Yes!
So glad you're here.
Thank you so much. Thank you.
Yeah. All right. Thanks everyone so much.
All right. This is really great. You can come too. Thank you.